Hi, welcome to part 2 of our tutorial on solving simultaneous equations using elimination. In our previous tutorial we did 3 examples, and the 3 examples were easier examples. In this tutorial I would like to look at 2 more examples, but these ones are harder ones and involve a bit more work. So first of all, let's look at example 4. Here it is, 3x plus 2y is equal to 6 and 4x plus 3y is equal to 10. Notice that both equations are in 2-intercept form here, so I must use the elimination method. However, when I look at the coefficients of x and y, I find that both pairs are different values. Here the coefficients of x are 3 and 4, different values, and the coefficients of y are 2 and 3, different values. So what do I do to eliminate one of the variables? First of all, I need to decide which variable I want to eliminate. I could eliminate the x's or I could eliminate the y's. Depending on which variable I choose, that will then determine what I multiply each equation by. I can multiply each equation by different factors to make one of these variables even. We could eliminate the x variable or the y variable, provided that we multiply each question by the appropriate factor. In this first demonstration, I'm going to eliminate the y variable. If I do that, I have to multiply each equation by a different factor. Let's start with equation 1. If I multiply equation 1 by 3, I will call it equation 3, and this is what it will look like. Here is equation 1 as it originally looked. 3x plus 2y is equal to 6. I multiply it by 3 and I get 9x plus 6y is equal to 18. Now I'm going to multiply equation 2 by 2 and I'll call it equation 4. Here's equation 2 as it originally looked. 4x plus 3y is equal to 10. I multiply that by 2 and I get 8x plus 6y is equal to 20. When I do this, I notice now that my coefficients of y in both equations are now the same. I can subtract one equation from the other to eliminate y. Let's see how this works. I'm going to take my new equation 3 away from my equation 4. And I have 9x minus 8x gives me 1x. 6y minus 6y gives me 0. And 18 minus 20 gives me negative 2. So x is equal to negative 2. Now that I have this one variable, I can substitute x is equal to negative 2 into equation 1 to find the value of y. Here is equation 1 as it originally looked. 3x plus 2y is equal to 6. But if x is equal to negative 2, it becomes 3 times negative 2 plus 2y is equal to 6. 3 times negative 2 is equal to negative 6. Negative 6 plus 2y is equal to 6. If I take the negative 6 to the other side of the equals, it becomes positive 6. 6 plus 6 gives me 12. If 2y is equal to 12, then clearly y must be equal to 6. So the solution to this system of equations is x is equal to negative 2 and y is equal to 6. This is a harder example because I have to multiply each equation by a different factor to make one of the variables even. In this example, I could have also eliminated the x variable first and still get the same answer. Let's look and see how that's done. If I want to eliminate x, I'm going to multiply equation 1 by 4 and call it equation 3. Here's the original equation 1. I multiply it by 4 and I get 12x plus 8y is equal to 24. Then I multiply equation 2 by 3 and I'll call that one equation 4. Here's the original equation 2 as it originally looked. I multiply it by 3 and I get 12x plus 9y is equal to 30. Now you can see that the coefficients of x are both the same value, 12, and I can subtract these two equations to eliminate x. So let's see how that looks. Here is equation 4, my new equation 4. Here is my new equation 3. I'm going to take away equation 3 from equation 4. 12x minus 12x gives me 0. They cancel out. 9y minus 8y gives me 1y. 30 minus 24 gives me 6. So now that I have y, I can substitute it into equation 1 and solve for x. Here is equation 1 again, but for y here, I'm going to put in the value 6. 3x plus 2 times 6 is equal to 12. 2 times 6 is 12, and when I take 12 to the other side of the equals, I will get minus 12. 6 minus 12 gives me negative 6. If 3x is equal to negative 6, then x must be equal to negative 2. So once again, I find that the solution to this system of equations is x is equal to negative 2, y is equal to 6. So you can see that it didn't matter which way I did this. If I eliminate y and solve for x, I get exactly the same answer as if I eliminate x and solve for y. So it doesn't matter which variable you decide to eliminate. As long as you multiply one or both equations by the correct factor and follow the correct processes I have just demonstrated, you should get the correct coordinates for your answer. Let's look at our final example, example 5. 6x plus 5y is equal to 3. 5x plus 4y is equal to 2. I'm going to eliminate the y variable here in order to solve. Firstly, I'm going to multiply equation 1 by 4. If I multiply 5y by 4, I'll get 20y. And I'm going to multiply equation 2 by 5. If I multiply 4y by 5, I will get 20y. So this is how it looks. Here is my original equation 1. I multiply it by 4. I get 24x plus 20y equals 12. I'll call that equation 3. Then, here is my original second equation. I multiply that by 4 and I will get 25y, sorry, that should be by 5. I get 25x plus 20y is equal to 10. Sorry, that's a mistake. That should be 5. 5x times 5 gives me 25x. 4y times 5 gives me 20y. 2 times 5 gives me 10. Now the coefficients of y are both 20 and I can subtract equation 4 from equation 3. This is how it looks. 25x minus 24x gives me 1x. 20y plus 20y minus 20y gives me 0. 10 minus 12 gives me negative 2. Now that I have x is equal to negative 2, I can substitute x is equal to negative 2 into equation 1 and solve for y. So here is equation 1 again. Where x is here, I'm going to substitute negative 2. 6 times negative 2 is equal to negative 12. So negative 12 plus 5y equals 3. When I take the negative 12 to the other side of the equals, it will become positive 12. So 5y is equal to 15. If 5y is equal to 15, then y must be equal to 3. So the solution to this system of equations is x is equal to 2, y is equal to 3. I hope you've found this tutorial useful. I'm sorry for the error in example 5, but I hope it's still been easier for you to follow.